Assalamualaikum. In today's unit, we will talk about water, its structure and its properties. As everybody knew, the chemical formula of water is H2O, that is two molecules of hydrogen binding with one molecule of oxygen to make a water molecule. Liquid water is the medium of life. Most organisms are over 80% of water. As you can see, the spinning structure of water. The red one is oxygen and the transparent white ones are the hydrogen atoms. Let's go deeper inside the structure of water. As you can clearly see, these two are the hydrogen molecules with one electrons in the outermost shell, and this is oxygen molecule which have two electrons in its outer electron shell. Hydrogen lacks one electron in its single shell. By sharing electrons, oxygen and both hydrogen complete their outer shells. The resultant compound is water, with properties unpredictable from those of its components, that is hydrogen and oxygen. As you can see, hydrogen molecule lacks one electron in its outermost shell, while the oxygen molecule lacks a whole 8 electrons, but it is holding 6 electrons in its outermost shell. So here shell 1 is completed with 2 electrons, and here the shell 2 is completed with 8 electrons. This is the text formula of water, and this is ball and the stick formula of water. You can see the angular formula of water too. So here we will talk about van der Waals radius of hydrogen, that is 1.2 amperes. Van der Waals force is a spherical field of influence around an atom. Atoms may intrude into one another's van der Waals field only up to a point. As you can see, oxygen produces an electron field that is tetrahedral in shape. Two hydrogen atoms are attached. However, as both hydrogen end up on the same side of oxygen, the water molecule has a loop-sided charge of polarity. Each water molecule can link to 4 other. Hydrogen bonds are weak electrostatic attractions between hydrogen and electronegative atoms, typically nitrogen or oxygen. Oxygen produces an electronic field that is tetrahedral in shape. Two hydrogen atoms are attracted. However, as both hydrogen end up on the same side of oxygen, the water molecule has a loop-sided charge. Polarity causes water molecules to attract one another as well as other charged molecules, as you can clearly see in the picture. That is bonding of hydrogen bond. Water molecules in air and liquid are always in motion, the more so as temperature increases. Here we see the lattice structure. We can pause it. Most of the time, two hydrogen per oxygen is the rule. Water molecules get along very well and lead an active social life. But on occasion, a hydrogen ion briefly escapes without its electron. This hydroxyl ion now carries a negative charge. The hydrogen ion carries a positive charge and temporarily joins another water to become hydronium. In pure water, the number of OH negative molecules equals the number of HCO positive molecules. Water ionizes to a very slight extent. Only 2 in every 555 million water molecules are involved at any moment. Water is particularly good at dissolving substances that ionize, but some of these ions upset the hydrogen hydroxyl balance. Chlorine hydroxychloric acid, HCl, is eager to ionize. Now there is insufficient OH negative to balance the H2O positive. Excess H positive or H2O positive means acid. The higher the concentration of hydrogen ions, the stronger the acid is. In water at room temperature, there is only one hydrogen ion for every 555 million water molecules. Expressed mathematically, the concentration of H positive is equal to 1 into 10 raised to power minus 7 moles per liter. If the concentration of hydrogen ions goes 10 times, that is, hydrogen ions of 10 raised to power minus 600 times is equal to 10 raised to power minus 5. You can do the math yourself. The pH scale is a conventional way of expressing hydrogen ion concentration by simply referring to its logarithmic power. In water at room temperature, the concentration of hydrogen ion is 1 into 10 to the power minus 7 moles per liter, where the minus 7, this number without its minus sign, is the pH. So its pH is 7. Definition: pH is the negative logarithm of hydrogen ion concentration. The pH scale was defined by Søren Sørensen, Danish biochemist, in 1909. It reduces a cumbersome number to a simple number. So the pH scale ranges from strong acid to strong base. Cellular processes are generally restricted to the middle of the scale between pH 6 and 8. Most of the food we eat is acidic. As you can see, corn, cans, carp, they are acidic. Distilled water, zone of life slider. You can move it and you can see different numbers and different fruits: onion, beet, bananas, tomatoes, oranges, olives, wine, grapefruit, lemons. These are acidic. When we move towards this side of the base, baking soda, borax, magnesium, you can see the numbers changing. The pH is 7.44. The concentration is this, equals to 3.63 e raised to power minus 8 moles per liter. The pH of an aqueous solution can be roughly measured with pH paper that changes color according to pH. Titration is the traditional method for determining pH, a tedious process greatly simplified by the invention of the pH meter in 1935 by Arnold Bachmann, 1900 to 2004. You can see the color range: pink, yellow to green, then blue and purple. Once more, we can move to the pH meter. It's up to 14, right? That is sodium, salt, NaOH, 14 pH. And if we move to the other end, this is 0, strong, HCl, hydrogen sulfide, HNO3, these have 0 pH. These are strong acids, digestive juices, pH 2, vinegar, 2.6 to 3, 4, beets, banana, mild, zone of life, ground beef, mushrooms, cow milks. These came all in the zone of life. Seawater is base. So, thank you. For more videos, subscribe to Subject Expert and do share the page and like it. Thumbs up. Thank you.